Okay, so let us walk through this graph of the rapid loss of Arctic sea ice. The first thing you need to look at is this explanation of what this falling graph is. It is ice volume average in the Arctic, and it's a 7-year ice volume average. And what is a 7-year average? Well, it's pretty obvious. It's a 7-year average. It's the volume for every day of 7 years averaged. So that means over here, the very first point is January 1st, 1986. So that's an average of every day from January 1st, 1979 to 1986. So that's 7 years in that very first point, right? And down in the end here, the "you are here" mark, you have the 7 years from September 2021 back to September 2014, right? So for every part of this graph or path, you have 7-year averages making up every point. Okay, so basically we are following how the 7-year average is developing from the very first satellite measurements in the 70s and 80s and down to the past weeks or months, like in August. And to borrow from today's show by Black Bear News, I'd like to use his example of his understanding of a tipping point. Although this, of course, is not a tipping point. That's been settled in Geneva by the IPCC, so it's may look like a tipping point, but it's not. It's just a graph representing a tipping point, as Magritte would say. Okay, so Kevin's example on Black Bear News was that you have a boulder, a giant stone or rock, and it's down here, and you get all your friends and family to help push that boulder up this little hill and down here, and it still sort of settles here. So you push it over this edge, and from there on, obviously, you don't have to push anymore, because the boulder can easily manage to get all the way down here without your help or any more pushing. Even this little hill here, it can get over because of the speed it's already got. So gravity would just take care of the rest, and it's the same for ice or climate tipping points. After a tipping point, it no longer needs the input that caused it to tip. So it doesn't need industrial emissions anymore. It doesn't need humans or civilized intervention or emissions or push. It just goes all by itself, because basically tipping point is passed, and so that then it's sort of self-driven for the rest of the journey. So that's that. And a lot of people actually, and quite a few climate scientists as well, are pretty open about this being a case of a tipping point, and that this sea ice tipping point also contributed to tip the Greenland ice, the ice sheet in Greenland, to tip around the millennium in 2000, 2001. But of course, we will never hear those words from the guys in Geneva. So let's just leave it at that, and then you can be the judge. Will you trust the IPCC or your lying eyes, as they say? Okay, so the speed of collapse, or the speed of decline from that previous graph, that's something we look at in this plot. And you remember it was a 7-year average, and so that's the middle one here. But I also present 4 other multi-year averages for the Arctic sea ice volume, and these 28 squares, they are just the latest 28 days of data that we have from PIOMAS, the Polar Research Center in Seattle. And you can see that the speed of collapse, or speed of decline, of the 7-year average is 1, and the key for that is up here. It's 1 cubic kilometer lost daily from the 7-year average. So every day this month and next month and probably next year, we will lose about 1 cubic kilometer from the long-term average of sea ice volume. And I've also included a little sort of helper on the end, because some of you are interested in when it all goes away, and when this all collapsing thing will happen when it comes to the ice. And as I indicate down here, this is not the blue ocean event. The blue ocean event is much easier to accomplish because it's just the virtual ice-free target of less than 1 million square kilometers. It's just requires 1 day of late summer ice-free. But in this case, we are looking for a half-year ice-free Arctic Ocean and neighboring oceans, so that it's much harder to get, let's say, April to November, if that's 6 months, to be ice-free or below 1 million square kilometers. So the estimate here is for 2045, if the speed of decline for the 7-year graph is the correct one to go by. But of course we don't know. We don't know if it keeps up at the same pace, and we also don't know if the 7-year graph is the most helpful. Therefore we have other choices or other options. So it's interesting to see that even the 25-year average also has a 1 cubic kilometer per day decline. You would imagine that it's harder to keep that kind of pace over 25 years of sea ice data, but that's the case. And we even have one faster, which is collapsing at 1.1 cubic kilometer per day, and that's a 20-year average graph. And just to explain the second last line here, this is just, because we have 28 days for this field, we have also 28 years listed down here. And that's just a representation of these guys over here. So it means we have estimates in 2043, 44, 45, 2048 and 2049. They are potential years when we might have half the year ice-free in the Arctic. Okay? That's all for now. Bye. Because the ice must flow.